11.5 is where we're going to find the volume of pyramids and cones. So for finding the volume of a pyramid, I'm going to do a third times the area of the base times the height. So just a little bit different than a prism and a cylinder. So here's my first problem. It's giving you that you have the entrance to a museum in Paris, France, and it's a square pyramid with a height of 21.64. So I did my best to draw it out over here. So you can just go ahead and draw in your base and then try and put your vertex of the pyramid off to the side. And so then I drew in that the height would be 21.64. So the height is always from the vertex to that center. So I kind of drew it in there. And then in the picture it didn't, or in the problem it didn't tell you, but it does in the picture. But the picture it tells you that the length of the base is 35.4. So make sure that you draw that in there as well. So if I'm doing a third times the area of the base times the height, I'm going to start with finding what shape my base is. Well, it told me that it's a square pyramid, so I know my base is a square. So to find the area of a square, I would do base times height. Well, both of these are the same, so that's why I'm doing a third times 35.4 times 35.4, and then timesing the height by the pyramid, which they said is 21.64. So multiplying all those together, I got 9,039.5 meters cubed. Okay, your turn. Do the got a question. So in the got a question, it said that you had the area of the base. They gave it to you already, so you didn't have to do any computing. You just had to plug it in its spot. It also told you the height, so again, just plug it in its spot, and then compute that product. So you should be getting 32,100,000 cubic feet. Okay, what happens if they don't give you the height? So maybe they give you the slant height, which is what's going on in this last question. So I'm still using the same formula, but just like before, if we were missing one of the pieces we need, we just have to do a little bit of extra figuring. So in this case, I do a third times, I need the area of the base, and again they told me it's a square pyramid, so my base is a square. So I'm going to do base times height, which is 40 times 40, which is why I wrote that there. Then I need to take it times the height. They do not give me the height in this case. They do give me the slant height, which is 25. I also know that this leg is going to be half of this whole side length, so that's how I know that this side is 20 of that triangle. Since I have two of the three sides of a right triangle, I'm just going to use Pythagorean theorem to find what that third side is. So I put 20 in for one of the legs and 25 in for the hypotenuse. So then I just computed. So I squared those numbers, subtracted 400 over, and then I did the square root. So I found the height using the Pythagorean theorem. So that's why I'm using 15 as my height there. So then I'm just multiplying those all out and I get 8,000 cubic feet. All right, let's have you try the next one on your own. So in the next one, it said another square pyramid with base edges of 24 and slant height of 13. So here was my pyramid that I kind of drew out, and then this was the right triangle to help me find my height. So I know that a side length of my triangle is half of the pyramid length, so that's how I know it's 12, and then the slant height was 13. So when I went through the Pythagorean theorem, I found that my actual height of the pyramid is 5. So plugging numbers in, I have a third times area of the base, which is a square, so I'm doing base times height, 24 times 24, times the height of the pyramid, which is 5. So you should be getting 960 cubic feet. Okay, you're going to notice that if I'm doing a cone, I have the exact same formula. I still have a third times the area of the base times the height. The only difference is every base of a cone is a circle. So we can just automatically substitute that area formula in there for capital B. So what's it look like when I'm doing that kind of problem? So here's a story problem if you want to pause it to read through it there. I did not put the picture in because it was very large, but you can just draw it in over here to the side. So to draw a cone, you're going to do a half circle and then do a dashed half circle on the back side because we can't see that, and then just do two sides of a triangle to connect it as a cone. So then I drew in my height, so I put in my dashed line, and I also drew in my diameter across that circle part. So then, if it's wanting me to find the volume, what I can do is just plug in my numbers in the formula. So I know that my radius is half of this diameter, so that's why I'm going to put 7 in the radius spot. And then the height of the cone is 12, so that's how I know that I can just plug that in there. It wants me to do the approximate value, so that means I'm actually going to find the decimal answer. So when I multiply all that out, I get 615.8 cubic feet. Okay, you have one more got it question to find the volume of that cone. So in your got it question, you are dealing with an oblique cone, which means that it's just shifted to the side. The height is not perpendicular up and down through the center. And so you're still going to use the same formula, and I would do 1/3 times pi times radius, which they told me is 6, squared, times the height of the cone, which is 12. So just plugging those numbers in. Now it did say write it in terms of pi and round, so I should have two answers. So if I left my answer in terms of pi, I would have 144 pi meters cubed. If it asked me to round it, then that's when I would put pi in as a decimal, and I would get 452.4 meters cubed. So pay attention to the directions. Do they want you to round it, or do they want you to leave it in terms of pi? Okay, so that takes care of the volume for cones and pyramids.